Okay, ladies and gentlemen, back to electronegativity. Now remember, electronegativity is kind of the opposite of ionization energy. It's how much the atom attracts electrons, not how much energy is required to remove them. And a brief note about electronegativity. Because electronegativity is about attracting electrons. The noble gases are unreactive. They do not attract electrons at all. They already have a full valence shell. So noble gases do not have electronegativity values. All right, so let's put this down here somewhere and use a different color for it, so perhaps dark blue. So noble gases, and that would be group 8A, do not have electronegativity, which is abbreviated with this Greek letter, values, because they do not gain electrons because they already have a full valence shell. So that's why you will not see noble gases with electronegativity values. And let me put a little box around that because that's really not part of the regular explanation. It's just an explanation for why noble gases don't have that. All right, so back to what we were doing. Well, it's all about attractive forces, right? So we have fluorine in period 2. So if we're going to go back along the period, we're going to go to lithium. And lithium has got 3 protons in it, in its nucleus. So I want to use the same color. So there we go. So lithium. So lithium has a positive 3 in the center, in the nucleus, and it's got 1, 2, 3 electrons. So you can see fluorine has got a positive 9, so it has a pretty large attractive force. But lithium, on the other hand, has only got a positive 3, so it's got a relatively small attractive force between the positive nucleus and the negative electrons. So it has a smaller attractive force. And it has exactly the same 2 energy levels as fluorine. So, same energy levels, smaller attractive force. So what that means is that as I go from left to right, from a small force to a large force, the electronegativity will increase across the period. Okay? So, across the period, electronegativity increases. Just exactly the same way that ionization energy increases. And so to make that point, I'm I'm not, because I'm going to have to copy that and it's going to be difficult. Okay, so to make that point, I'm going to try to find where I was again. There we go. To make that point, I'm going to switch to green and use basically the same kind of argument that I was using for ionization energy. All right, as you go across a period from left to right, the positive nuclear charge increases. So the attractive force on the valence electrons increases. And the atom attracts electrons in a bond more strongly. Because remember, electronegativity is attraction for electrons in a bond, right? And so because of that, we say attracts electrons in a bond more strongly, right? That's what electronegativity is. All right, so there's your across the period trend.